basically the parameters we need to take care as far as the engine performance is concerned. It's all about indicated power, brake power, friction power, and certain efficiencies. So let us discuss all these parameters one by one. The very first parameter is all about indicated power. Indicated power is nothing but it is power developed by the engine which can be easily obtained using indicated diagram. Now indicated means here indicated is nothing but it is effective pressure, and just by determining the effective pressure you can substitute the value of like effective pressure into this equation. That is what indicated power is equivalent to PM LAN by 60,000, and you will get this indicated power in terms of kilowatt, where PM, that's PM is nothing but it is mean effective pressure, normally derived in Newton per meter square. Here L is nothing but it is length of stroke in meter, and A is nothing but it is cross section area of the piston in meter square, and N is nothing but it is number of working strokes per minute. Let me tell you that for 4-stroke engine, that N, like number of working strokes per minute, it's normally taken as N by 2, whereas for 2-stroke engine N is taken as N, means number of working strokes per minute. So this is all about indicated power. Okay, next is brake power. Now brake power is shortly known as BP, and brake power is nothing but it is the power available at the output shaft. Now this power can be determined using a device known as dynamometer. However, certain different types of dynamometers are there, but you can simply use dynamometer to calculate the brake power. Now in brake power, the equation if you just refer, then brake power is nothing but it is equivalent to 2 pi nt by 60,000 kilowatt. Again I am repeating, brake power is nothing but it is equivalent to 2 pi nt divided by 60,000. Again you will get this in kilowatt, whereas capital N is nothing but it is revolution per minute of shaft. We just need to calculate revolutions per minute, and T is nothing but it is torque. Torque is nothing but it is like a force into its perpendicular distance. So if you can calculate these two things, you can easily substitute into the primary equation and you will get the value of brake power. Indicated the power developed by the engine is greater than brake power. So one parameter we need to take care, that is known as friction power, shortly known as FP. Friction power is nothing but it is the power lost due to friction. Now this is nothing but it is the difference between indicated power and brake power. So friction power is nothing but it is the difference between indicated power and brake power. Indicated power minus brake power, because indicator power is greater than brake power. So this is about friction power. Now let's discuss about efficiencies. In efficiencies, in order to compare two different engines, we need to take few efficiencies into the consideration. This is what about the list. The very first is mechanical efficiency. The second one is thermal efficiency. The thermal efficiency is further categorized in two different categories: indicated thermal and brake thermal. The third one, air standard efficiency. Fourth, relative efficiency. And fifth, volumetric efficiency. Let us discuss all these efficiencies one by one. First of all, mechanical efficiency. Now, mechanical efficiency is basically given as eta mech. Eta mech is nothing but it is the ratio of brake power to indicated power. So, mechanical efficiency, it's nothing but eta mech is equal to BP upon IP. So, BP is brake power, IP is indicated power. Okay, so this is about mechanical efficiency. Next is thermal efficiency. Now in thermal efficiency, as we know, there are two subcategories. One is indicated thermal, eta IT. Now eta IT is nothing but it is indicated power divided by fuel supplied into its calorific value. This equation is used to determine indicated thermal efficiency. Again I am repeating, eta IT is nothing but it is indicated power upon fuel supplied into its calorific value. Similarly, brake thermal efficiency, eta BT, is nothing but it is power delivered in kilowatt divided by fuel supplied into its calorific value. Next in the row is all about air standard efficiency. Now air standard efficiency, there are two equations. The first equation belongs to the petrol engine and the second equation belongs to the diesel engine. The equation of eta air means efficiency of air standard, which is equivalent to 1 minus 1 upon r raised to gamma minus 1, whereas gamma, you know that gamma is nothing but it is adiabatic index. Gamma is equivalent to adiabatic index and r is nothing but it is compression ratio, which is normally given by V1 upon V2. और जो सेकेंड इक्वेशन है फॉर diesel engine, so that equation is nothing but eta air standard is equivalent to 1 minus into bracket beta raised to gamma minus 1 upon r raised to gamma minus 1 into r into beta minus 1, where जो beta है, like beta is nothing but it is cutoff ratio, and cutoff ratio is basically it's a ratio between V3 by V2. Okay, next is relative efficiency. Now relative efficiency is nothing but is the ratio of indicated thermal efficiency to air standard efficiency. So that means eta relative is nothing but it is equivalent to eta IT upon eta air. Volumetric efficiency. Now volumetric efficiency is nothing but it is the ratio of actual volume of charge taken in at ambient condition to the swept volume. Eta volumetric is equivalent to actual volume of charge taken in at ambient condition to swept volume. Now this is what the charge means whatever taken volume in volume taken during the suction in ambient condition to the swept volume. Now swept volume is nothing but it is this volume swept away by the piston when it moves from TDC to BDC or BDC to TDC. So this is the end from my side as far as the performance parameters are concerned. Thank you.